Let's be honest, you guys deserve a break after yesterday. It was a pretty rough math class, wasn't it? We had 10 problems, had to splice videos. I think I had, 4 problems, and then I had to erase and put 6 more on at the end, something like that. Well, as you'll see behind me, for today, I have 4 problems on the board. But guess what? When we get done with those 4 problems, guys, we're done for the day. I don't think it's going to take any more, probably like 10 or 15 minutes. So again, I feel like you guys deserve it. Great job working, plugging through. I know what wasn't just an easy lesson yesterday. But our lesson today, again, it's not going to take as long. It's going to be pretty simple. We're going to be dealing with the sums, meaning adding together, as well as the differences, which means subtracting, radicals, which are numbers that are under a radicand, or numbers that have the square root being taken of them. Okay? And here's what we're going to do, for instance, on number 1. When you have something like 6 times the square root of 7 plus 3 understood times the square root of 2 minus 2 understood multiplied times the square root of 7, I want you to look at something. There are 2 square root numbers that are the same. And because of that, we can add or subtract, depending on the signs, the numbers that are in front of those. Okay? So let's do exactly that. How about this one? If I have the same base of the square root of 7, I can take the numbers in front, which are 6 and negative 2, or maybe better stated, minus 2. I can subtract 6 minus 2, understood both of those are to the square root of 7, okay? And if I understand that, I'm not even going to write that. I'm just going to do 6 minus 2, which is 4. But I have to make sure to reapply, then, my base, kind of like in the denominator, or like with a variable, if you're adding and subtracting, you have to have the same base. You keep the base, but deal with the numbers in front. Well, it's the same thing right here. Or in a fraction, keep the denominator, just deal with the numerators, the numbers on top. Well, same thing, you just deal with the numbers that are in front of the common base, which is the square root of 7. And so what I have is now simplified. These two, combining them, is 4 times the square root of 7. Does that make sense? Because I dealt with the numbers in front, but I didn't mess with the base. Okay? 4 square root of 7, and I have to rewrite that middle term, with which I could do nothing because its base wasn't the same as these two. So I have 4 to the square root of 7 plus 3, the square root of 2. Just rewriting that one. So does that make sense to you? Not really that difficult of a concept. You just combine like terms, and what determines whether your terms are alike is the base, or whether the square roots are the same. Now you're really going to like number 2. Look down here. I have 4 times the square root of 2 minus 3 times the square root of 5 plus 2 times the square root of 7. Now, is any of these bases, are they the same as one another? Is 2 the same as 5? Is 5 the same as 7 or 2? None of them have the same base, and they're all prime numbers, meaning the only factors of those terms are the number itself and 1, and therefore, guess what, guys? I don't know how you want to express it, but just say, check mark, I'm done, because there's nothing to do on that one. I told you, you'd really like that one. That's really easy. However, watch out for ones like these. These are a little bit different. On number 3, I have the square root of 27 plus the square root of 12. Okay? Square root of 27 plus the square root of 12. Now, are the bases the same? No. But let me show you how you can still simplify these, because the difference between these two numbers and these 3 terms down here is that these were in prime form, meaning you couldn't break them down any further. Now number 3 is different because you can break down each of these further. And here's the way we're going to do that. For 27, what number is there as a factor of 27 that is, of what you know, a perfect square root. How about this number? 9. Because the square root of 9 is, get rid of the square root symbol, 3, because 3 times 3 gets you to 9. Well, what other factor is there of 27 that when combined with 9 gets you to 27? And that's the factor 3. Okay, you see what I've done here? I've just rewritten the square root of 27. I've done so with two factors of 27, 9 and 3, but I made sure to choose one of those two factors that is a square root or a perfect square of itself. And so, because 9 is a perfect square root, or I keep saying that, you know what I'm trying to say. Because 9 is a perfect square, and when I'm taking the square root of 9, what is that? Meaning, what times itself gets me to 9? That's the number 3. And guys, I can take the square root of 9, and I can move that outside of the square root symbol. And so that I have the square root of 9, which is 3, on the outside. But look, the other factor, which is prime, I can't do anything with it. And so I leave that under the radicand. Okay? I take the square root of 9, and since it's 3 and just a whole 3, I can move that to the outside of the square root symbol, and it leaves me with 3 underneath. Now, let's do something similar right here. When you look at the number 12, what are two factors of 12, one of which is a perfect square? Any ideas? How about this? 4 and 3. Because 4 times 3 gets me back to 12. And so writing this under the square root symbol instead of 12, it's exactly the same thing as 12 because they're both multiples of 12. The reason though, guys, I chose something like 4 and 3 instead of 6 and 2 is because the number 4 is a perfect square. What times itself gets me to the number 4? And that number is 2. And therefore, I can move the square root of 4, which is 2, to the outside or to the left of the square root symbol. But what I can do nothing with is the number 3 because it's in prime form and it is not a perfect square. And so I have to leave that under the square root symbol. Now look at what I have simplified. I have 3 times the square root of 3 plus 2 times the square root of 3. Do you see something kind of neat right here? Do I now have the same base? Yes, even though I didn't start with it, I have taken it into the same base. And now what I can do is add those numbers that are in front of the square root symbol since I have the same base. And because of that, I'm going to keep as my answer a base of the square root of 3, but I'm going to add those numbers in front, the numbers 3 and 2. What's 3 plus 2? No, not 4. Not 6. 3 plus 2, we know that one. I'm just giving you a hard time. Is 5. And so my answer is 5 times, keep your same base when you're adding or subtracting radicals, the square root of 3. That's pretty neat stuff, isn't it? Okay, let's do one more. That's slightly child's play, I do have to admit to you. This one's going to be some slightly more complex stuff, what we're doing in number 4. Okay, number 4. We have 4 different terms, and what we're going to do is just break down each one of those, okay, into its factors, because none of these is a perfect square, but every one of these 4 contains a perfect square as a multiple of that number. For instance, the first one, just rewrite what's on the outside of the parentheses, 3 times, okay, the square root of 8. Well, let's break down 8 into a couple of factors. Obviously, the only 2 choices that we have, if it's going to be put into anything other than itself in 1, those numbers are going to be 4 times 2. Okay? 4 times 2. Let's just move on to the next one. Minus 2, square root of 18. Now, what is a factor of 18 that is is a perfect square of itself. I can't use 6 and 3 as factors, even though they both are, because neither one's a perfect square and that doesn't help me out any. What I can use, though, is 9 and 2. The reason I use 9 and 2 is because 9 is a perfect square. Move on to the next one. Minus, okay, there's nothing that's in front of that we can see. It's implied that it's a 1. It's an imaginary 1 between that minus sign and the square root symbol. Okay? I'm going to write that not in simplified form, but as I'm doing calculations, because that's going to help us. What I need to do is break down 12 into two factors, one of which is a perfect square. I'm not going to use 6, and like we discussed up here, I'm not going to use 6 and 2 because neither one's a perfect square. Instead, I'm going to use the numbers 4 and 3 because one of them is a perfect square. Okay, I've run out of room, but I'm going to write this next term right down here. Plus, understood, plus, and I'm going to write it right down here, 4 square root of, okay, I need to ask myself, what are two factors of 50, one of which I need to be a perfect square to break this down further? Now, I could look at 5 and 10, but that's not going to help me any because neither 5 nor 10 is a perfect square. And I could do all the individual prime factors and the way we went about it yesterday, but I'm showing you what, in my opinion, is a little bit of a shortcut. And also, I'd like for you guys to be really versatile and not only be able to attack a problem one way, I want you to be able to attack it as many ways as possible. But I really do think this is a simpler way of doing it. Okay, what is a factor of 50 that is a perfect square? How about this? 25 and 2. A really simple one off the multiplication chart, but 25 and 2. Why would I choose 25? Because 25 is a perfect square. It's going to help to break things down. All right, now here's what I do from this point, all that I've done in getting these multiples down. I'm going to move the numbers that are perfect squares after I take the square root of them to the outside. And when you do that, listen to me closely, you multiply because this is being multiplied to that and that's being multiplied to that. To move it, you multiply whatever the square root of that number is you're moving to whatever's on the outside of the square root symbol. And so the square root of 4 is what? What number times itself gets me to 4? The number 2. And so I'm going to move 2 to the outside so that I'm going to have 2 times 3 square root of whatever's left underneath, which in this case is the number 2. It's prime and it's not a perfect square, so it stays under. Okay? Then I'm going to have minus 2. Okay? Same thing here. But I'm going to take the square root of 9. That's a perfect square. What number times itself gets me to 9? The number 3. And therefore I'm going to take the square root of 9, which is 3. I'm going to move it out here, and since that's being multiplied to everything under there, I have to keep it that way whenever I move it out and multiply negative 2 times 3. But I leave underneath the radicand, I leave the number with which I can do nothing that's prime. And that again is the number 2. Okay, right over here, minus 1, okay? But I have the square root of 4. What number times itself gets me to 4? That's the number 2. So in taking the square root of 4, which is 2, I'm going to move that to the outside of the parentheses, and I'm going to multiply that negative 1 times the number 2, and I keep under my parentheses that with which I can do nothing, the prime number of 3. Okay? Now, I think what I'll do is rewrite this up here so it doesn't get confusing. That plus is going to go up here. I'm just rewriting here because it's kind of getting in my way. That's all I'm doing. 4 we had times the square root of 25 times 2. Okay, that enables me to get rid of this and just really, truthfully, just get it out of my way. Okay, so there we are. That's out of our way. Now, what we have up here is plus 4. Okay, plus 4. times the square root of 25 times 2. What's the square root of 25? What number times itself gets me to 25? The number 5. And so what I'm going to do is move the square root of 25, which is 5, to the outside. But remember, all that's being multiplied to each other. So I'm going to put that 5 times the 4 and leave underneath that with which I can do nothing, the prime number of 2. And it's the square root of 2, and that's not a perfect square, so I keep it in that spot. Now I'm going to rewrite everything that I have here. This is a complex one, isn't it? Stay with me all the way to the end. We're just about there. What's 2 times 3? 2 times 3 is 6. So I have 6, keep, square root of 2, minus, what's 2 times 3 again? Same thing it was a moment ago. That's the beauty of math. 6, square root of 2. All right, then I have minus, what's 1 times 2? Obviously 2. Keep my base, times the square root of 3. What is, I'm going to write plus here. What is 4 times 5? 4 times 5 is 20. Keep my base, square root of 2. Okay, I'm going to ask myself now, what terms do I have in common? In other words, what terms up here have the same base, or what terms are having the same square root taken from them? Square root 2, square root 2, square root 2. So guys, all I do is keep that base, the square root of 2, and I just combine the numbers that are in front of those 3 terms. What's 6 minus 6? Goose egg time, 0. And what I have left here in the commonality of those 3 terms is a positive 20. So between these two, that's 0. What's 0 plus 20? That's the number 20. I keep my base, square root of 2, okay? And the only number I have left is this one now right here. And I have nothing else in common with it, so I just rewrite minus 2. Don't try to combine these because they have different bases, and you cannot add or subtract terms that are different in base. So what I have is 20 square root of 2 minus 2 square root of 3. And guys, that is my final answer. And not only is that my final answer, but that's the last thing we're going to do in math class today. And even if some of this was a little confusing, that last piece of info, that's pretty good news, isn't it? That's not too bad. So that's all that we have. If you guys are having any trouble with it, let me know. Again, I've gotten some feedback, and what I have gotten has been very positive, and I hope that's continuing. But I think it's kind of fun what we're doing. It is a little bit mind challenging, but that's good for us. We don't want our brains to get stagnant and rusty. All right, guys, that's all that I have, and I will see you tomorrow.